In this episode, we're going to look at how to configure IPv4 and IPv6 static and default routes. I'll show you how to do it, and we'll talk about the concepts along the way. Now, in this activity, we're going to configure IPv4 and IPv6 default static and floating routes. Some of the things we're going to talk about may not reflect best networking practices, but it's to demonstrate how to do these concepts. We'll be configuring static routes, default routes, floating static routes for both IPv4 and IPv6. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Configure IP version 4 and IP version 6 static and default routes. Here I have my packet tracer lab open on the left side. That's where we'll do all our configuration, check our setups. On the right side, I have the normal packet tracer activity window open. That's where we have all of our instructions and IP addressing. When we look at our packet tracer activity window here, we see that we have our addressing table. It gives us our devices, what the addresses are, what they're already configured as. So we have an edge router, 2 ISP routers, 2 PCs, and a customer service server. When we look over here at our topology, we can see these networks. Coming off of our edge router down, we have 2 local area networks. So that'd be like 2 parts in your company, 2 different buildings, something along that line. This local area network right here is local area network 1. This one right here is local area network 2. They have different network addresses associated with them, both an IP version 4 and an IP version 6 address. Then we have the connections from our edge router to ISP routers. ISP has 2 different routers that allow us to get us some redundancy, also get us to have a floating static route in there. Then the ISP network is all of these devices. It's the it's the Ethernet connections, it's the switch, and it's the server. Now, when you first configure your network and you put IP addresses in, the router only knows about the networks that are directly connected. Over here on our edge router, the edge router only knows about the directly connected networks. There's 4 directly connected networks: LAN area 1, LAN area 2, and the 2 WAN connections to your ISP. It does not know about this internal network over here. That's the remote network. It does not know about that network. That's where we're going to have to set up our static routes to point to this network, and then even we'll have a host static route in there to point to this server. Remember, traffic travels both ways. So PCAs connecting to the customer server also has to send back some information. Now, that means that we have to set up some static routes on ISP1 and ISP2 for both LAN 1 and LAN 2. If you look at the ISP routers, each of them have 2 directly connected networks: their WAN connection and their LAN connection into the ISP network. They do not know about the 2 LAN networks over here. They don't know about LAN 1, LAN 2 because those are remote networks. We have to go through another one. We're going to have to set up static routes for those. Here's our objectives, basically explaining what I just said, and down to our instructions. On our instructions, they're going to have us go through and set up the routes. And we're going to set up IP version 4 and IP version 6 routes. Now we can start part 1. Part 1, configure IP version 4 static and floating static default routes. Step 1, configure an IP version 4 static default route. On the edge router, configure a directly connected IP version 4 static route. This is the primary route and should be through router ISP. Okay, let's look at this. So we're looking at edge router here. We're going to create a static route here. We're going to say directly connected Directly connected means it goes out one of the exit interfaces, and then we're sending this to ISP1. ISP1 is up here. And what we're looking at is this connection right here, the top right one on the edge router. If we click in the window and mouse over it, it'll show us that it's serial 000. That's what we want to set as our exit interface, serial 000. It's our directly connected default static route. Once again, this is a special one. The default static route is the route we use if there's no matches in our routing table. We're going to send all traffic to this default static route. And what happens here is PCA or PCB is going to try to browse to the ISP network over here on the right side. It's going to send some traffic up here to the edge router. Edge router is going to look at its routing table. It may or may not have any information on how to get there, and if it doesn't, it's going to look and see, do I have a default route? It's going to have a default route that points to the ISP router up over here. It'll send that traffic there, then hopefully the ISP router can handle that. If not, it'll go to its default route. And let's go ahead and set this up. I'm going to click on the edge router, bring this up, make this window a little bit bigger. There's no password set up, so we can just hit enter. Type in enable, brings us to privilege exec mode. The setting of the static routes, whether it's a normal static route or a default static route or a floating default static route, is done in global configuration mode. We need to enter into global configuration mode, type in config T, there we are, and now we can go ahead and start entering in the commands. First word is IP because it's part of the IP suite, and we're dealing with routes, so it's IP route. And now we can start entering this in. This is normally the destination network, but we're going to do this special default network where we want to take all traffic. We're going to match all traffic to this and send it that way. We process all the other routes in our table. If nothing is there, we're going to send it off to this default route. Now to do that, we use something here special. It's 4 zeros. A lot of people call this quad zeros. It's just easier to say. And so that's our network address. And then we need to do the quad zeros again for our subnet mask. So you do quad 0 space quad 0, and now we can put our exit interface to make this directly connected route out of our router. Once again, if I click in this window, this is the one we're looking. I can mouse over it and it will tell me it's serial 000. So I got IP route quad 0, and now I can put S0/0/0 in there, and I'll route it out that exit interface. Default route without a gateway, if not a pinpoint, may impact performances. That's just a warning right there. This is okay for us in our situation. On to step 2. Step 2, configure an IP version 4 floating static route. We're going to create a floating static route. Now, that floating static route, that's a backup static route. If the main primary static route goes down, this floating backup route or floating static default route will take over. Now, how do we make it a floating static route? When we enter in our command, there's an option at the end. So first time we entered it here, we did IP route quad 0, and then serial 00. There's an option we could have put at the end. We could have put a number that would specify the administrative distance. By default, the administrative distance for a static route is 1. It's very highly trusted. Remember, the lower the number for a static route, the lower that administrative distance, the lower number for that trustworthiness, that's the one it's going to use. And so we get a 1 for the primary one. For our floating default static route, we're going to give it a higher number. Let's go ahead and set that up. And so we start off with IP route again, and we enter in our quad zeros because we want to take our anything that makes it here, we're going to send it out that exit interface. So quad 0 for the network interface, quad 0 for the subnet mask. It's a different exit interface this time. First one we sent out to serial 000, which went up to ISP1. Now we want to send the floating static route to ISP2. To get that, what I'm going to do is I'm just going to mouse over this green triangle right here. And now it says it's serial 001. That's what we want our new exit interface to be. I'm going to go ahead and put serial 0/0/1 in there. And then this is where we had that optional administrative distance there. I'm going to put a space and a question mark. And notice we could either hit enter. If we didn't enter in anything, that gives us the default value of 1. That's what we did up here in the primary one. But we want to set one as a backup. We want this to be used in case the other one's not available. So we give it a little bit higher administrative value. Our instructions say we're going to set it as a 5. And if we look here, the options say we can go anywhere between 1 and 255 for administrative distances. But as soon as we get up to 90 and above, we start interfering with the dynamic routing protocols. So 5 is a good number. And so I have IP route, quad 0, and then we have our exit interface, serial 001. Then I put a space and then a value of 5 in there. That's the floating stack route. If the primary goes down, this will take over. We set that one up. Good job. On to part 2, configure IPv6 static and floating static default routes. Just like what we did in the previous 2 steps with IPv4, we're going to do IPv6. I'm going to minimize this. On the edge router, configure a next hop static default route. So on the edge router here again, next hop static default route, primary default route should be going through ISP. So that goes up to here. And what we want is the next hop. When we did IPv4, we did directly connected. That's the exit interface. Now we're looking at doing next hop. That's the next hop IP address. So instead of using the exit interface off the router we're on, we're going to use the next hop IP address. And how this works is this next hop IP address needs to be on a directly connected network. I need to know how to be able to route to it, but it can't be my IP address. I have to be able to send it to a device that has an IP address on the directly connected network. Once again, we're looking at going from the edge router to ISP. So we're looking up here at this configuration. Traffic is going to go from the edge router. It's going to go up here to the ISP. The next hop IP address, this is the next hop IP address right here. This is what we're looking for. We're looking to set that up. And now we need to get that IP address. If we mouse over, we can see that this is the serial 000 interface. We scroll up to the ISP router, the serial 00 interface. IPv6 address is right here, 2001 DB8:A:1:1. We don't have to specify the prefix at the end, but we just need this full IPv6 address. Okay, I'm going to click on this router here, on our edge router, come in, start entering in our information. Now, we're dealing with an IPv6 static route, so the command here is IPv6. IP was for IPv4. Now we're dealing with the IPv6 protocol suite. So our first word here is IPv6, then it's route, then it's our destination network. Once again, we don't care what it is. And so for IPv4, we used quad 0. For IPv6, what we're going to use is a :/0. That says our network portion of our IPv6 address is all zeros, essentially kind of what we have up here for the IPv4 quad address. And then our prefix is zeros. We're going to match everything. If we look in our IPv4, we had quad zeros there. Basically, we have all zeros again, but in IPv6 format, we put 2 colons, a /, and a 0. That takes care of it. And then we put in our next hop IP address. Our next hop IP address is over here from our routing table, 2001 DB8:A:1:1. Go ahead and enter that one in, 2001:DB8:1:1. colon A colon 1 double colon 1. Once again, you don't have to specify the prefix or the subnet when you're connecting to an established IP address, IP version 4, IP version 6. You don't have to specify that. If you're setting up that address, that's when you need to put the prefix or the subnet mask on there. Here we're connecting to, or we're routing to an established IP address. We don't have to worry about putting the prefix in there. This is our command here, IPv6 space route space colon colon /0. That takes care of matching anything that makes it to this point. And then a space, and then the next hop IP address, 2001 colon DB8 colon A colon 1 double colon 1. That takes care of part 2, step 1. Let's go ahead and look at step 2. Configure an IPv6 floating static default route. Basically the same as what we've done so far. So on edge router, configure a next hop IP address, IPv6 floating static default route. The route should be through ISP2 an administrative distance of 5. Once again, the administrative distance of 5 makes it that floating static route, that backup static route. Okay, starting off our command, IPv6 space, and we're dealing with the route again. So our word is route. We're going to match everything to this colon colon /0, and then our next hop IP address. Our next hop IP address, we're looking at the connection here between the edge router down to the ISP. We're looking at this connection. The next hop IP address has to be on a network connected to me. That would be this WAN connection right in the middle here. That'd be this WAN connection right here. But it can't be an IPv6 address on the edge router. It has to be the IPv6 address on the far side. What we're looking at is this connection right here on the ISP2 router. If we click in the window and mouse over the triangle, it'll say on ISP2, we're looking at serial 001. I can go ahead and scroll up in my instructions, look at ISP2 serial 001, and here is the IPv6 address, 2001 DB8 A2 double colon 1. You can go ahead and put that in there, 2001 colon DB8 colon A colon 2 double colon 1. And remember, we're doing the floating default static route. We're making it the backup, so we have to give it a higher number than the default. Default was 1. Our instructions tell us 5. That's a great number to do. Go ahead, put a space 5 in there, and that will give us our floating default static route for IPv6. That takes care of all of part 2. On to part 3. Configure IP version 4 static and floating static routes to the internal LANs. When we look at what we did right here, we've created paths that point traffic from LAN 1 and LAN 2 up to the ISP routers to be delivered to its destination. Now, when we send out a request, normally we want to reply. Whether that's like ping, you send out an echo request and you want an echo response back. You send out a web page request, you want to get that web page back. And so it's a round trip process. Right now, we have pointed traffic from LAN 1 and LAN 2 to the customer service ISP network. But now traffic can't make it back because we don't have any routing set up that way. What we're going to do is we're going to set up some static routes from the ISP network here on ISP1 and ISP2 and point that to the edge router so we can deliver LAN 1 and LAN 2 information back to where it started from. First thing we're going to have to do, step 3, part 1, configure the IP version 4 static routes to the internal LANs. When we did it the first time, when we did LAN 1 and LAN 2 traffic, we set up default routes. And we said, we're going to look at all of our routing table. If nothing matches default routes, we're going to push it that way. Now, instead of setting up default routes back, what we're going to do is we're going to set up static routes, and we're going to point specific traffic back to the destinations. And we're not going to use quad zeros. Those default static routes we did first, use the quad zeros. Now we're actually going to use network addresses. Part 3, step 1, configure IPv4 static routes to the internal LAN. Step A, on ISP1 is right here. Configure a next hop IPv4 static route to LAN 1 network through edge router. So next hop IP address for ISP to the edge router is this network right here, but it's this address down here. It's on a network that's connected to ISP, but it's not the address that's on ISP. It's that next hop IP address. We're looking down here. It's a static route to LAN 1. Here's the LAN 1 information. If we look at that, it says 192.168.10.16. That is a network address. You're going, no, it's not. It doesn't end in zeros. Have to remember, the computer sees it as binary. That 192.168.10.16. It sees it as a string of 32 ones and zeros. Write that out, convert that all into binary, then take your subnet mask, a /28. Put 28 ones at the beginning, and then fill in with zeros at the end. And where those ones change to zeros, draw a line between that IP address that you entered in, that network address, and the subnet mask. Then you have your host portion on the left side, you have the network portion on your left side, the host portion on your right side, and you'll notice that that host portion for 192.168.10.16/28, that host portion is all zeros. When that host portion is all zeros, that's a network address. These are network addresses. Okay, let's go ahead and enter in this static route here. We are doing this on ISP1. Slide this over, make it a little bit bigger. We don't have a password set up, so we can just hit enter, type enable to get into privilege exec mode. And then the static routes, once again, are done in global configuration mode. Go ahead and type in config T. And we are in global configuration mode. To set up our IPv4 static routes, we start off by IP because it's part of the IP suite. We're dealing with routing, so we put in the next keyword of route, and now we want to put in our destination network. We're on ISP1. Where is the traffic going to? The traffic is going down here to LAN 1. This here is our network address, 192.168.10.16/28. Go ahead, let's enter in that as our destination network address, 192.168.10.16, and then we put in our subnet mask. If you take the /28, convert that back into dotted decimal notation, the /28 converts into a 255. Oops, I got to put in 255. So starting over, it's 255.255.255.240. That is the subnet mask for that destination network of LAN 1. And then we have to put in the next hop IP address. We're on ISP1. We're connecting into the edge router. So it has to be on the same network, but it can't be the IP address on ISP1 because that's where we're starting. It needs to be the next hop. What we're looking at is this IP address down here on this interface. If I click in this window, mouse over the green triangle, it says this interface is serial 000. So on edge router serial 000, we scroll up to our addressing table, edge router serial 000. This is our next hop IP address, 10.10.10.2. We can go ahead and enter that in here, 10.10.10.2. That gives us our final command looking like IP route 192.168.10.16, 255, 255, 255.240, and then our next hop IP address of 10.10.10.10.2. There's only 3 tens. I lost count on how many I said, but 3 tens and then a .2. Takes care of A, and then on to B. Step 1B, on ISP1, configure next hop IPv4 static route to LAN 2 network through the edge router. It's going to be almost identical to what we did. So we're going from ISP router to the edge router to LAN 2. First one, we did the same path, but we went to LAN 1. Everything will be the same except for our network address. Because the network address on LAN 2 is different than the network address on LAN 1. The next hop IP address is going to be the same. That's this interface right here. Our network address for LAN 2 is 192.168.11.32. You're going to say, that's not ending in zeros. Once again, if you write that out in binary, you take the /27, put 27 ones, and followed by zeros to fill in up to 32 bits, that host portion is going to be all zeros. So that is a network address. Let's go ahead and enter this in. IP space route. Our network address here is 192.168.11.32, and then our subnet mask is a /27. If you convert the /27 into binary, you will get 255.255.255.224. So the fourth octet is a .224, and our next hop IP address, that was the same address we just used in that previous statement here, which was 10.10.10.2. That creates static routes from ISP to both LAN 1 and LAN 2, those two commands. Okay, part 3, step 1 is done. On to step 2. Step 2, configure IPv4 floating static routes to the internal LANs. Once again, very similar to what we just did, except we're going to create that floating static route through ISP2, that backup route through ISP2 in case ISP1 goes down for whatever reason, we can still get traffic to our destination. Step 2A, on ISP1, configure a directly connected floating static default route. Directly connected means we're using the exit interface. Floating static route means we're going to specify an administrative distance higher than 1 to make it the backup route to local area network 1, bottom left network here, through the ISP2 router. Now, this backup route is going to take us from ISP1 to ISP2, and then on ISP2, we're going to set up a route from ISP2 to edge router. So if the connection between edge router 1 and 2 gets down, it's going to see, okay, we're going to take the backup connection, or we're going to take that floating static route, point it down to ISP2, then ISP2 will have a static route that points to the edge router to get it to its destination. Use an administrative distance of 5. Okay, so let's get back on ISP1. First one we're doing here, directly connected floating static route to LAN 1. LAN 1 network address here, once again, is 192.168.10.16. You can go ahead and type IP route destination network of 192.168.10.16 with a subnet mask at 255.255.255.240. That's our /28. And then we want the exit interface for ISP1 to get to ISP2. I'm going to go ahead and click in this window, mouse over this triangle, and it's going to say we need gig 00. That's what I'm going to go ahead and type in here, is G0/0. And because this is that floating static route, it needs to have an administrative distance higher than the default of 1. Instructions tell us we need to set that as 5, so go ahead and hit space 5. So our command here is IP space route space 192.168.10.16. That's the network address of LAN 1. Space 255.255.255.240, subnet mask of LAN 1. Exit interface of gig 00, that takes us from ISP1 down to ISP2, and we have a 5 that specifies it as the administrative distance of 5, which is higher than the default of 1, which makes this that we're entering right now the backup or the floating static route. Step 2B, We have to do it for LAN 2. Same thing we just did, but now we have to do it for LAN 2. We're going to have it go down to ISP2 and then over to the edge router. Start off our command, IP space route, LAN 2 network address, 192.168.11.32. Go ahead and type that in, 192.168.11.32. And our subnet mask is /27, which is 255.255.255.224. Exit interface. Once again, I'm clicking the window. Exit interface to get from ISP1 to ISP2. This triangle, which is gig00. So G is 0/0. And we have to specify an administrative distance. We're going to put 5 in here. That sets it higher than the default, which makes it the backup route. That takes care of part 3, step 1, and step 2. On to part 4. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Configure IPv6 floating and static routes for the internal LANs. Now we're going to go ahead and on ISP1 configure those static and floating static routes for IPv6. Jump on to ISP1 here. We're looking to create the default routes, static routes, next hop, so we got to have the next hop IP address on ISP1 for LAN 1 to the edge router. So we're going from ISP1 here using the next hop IP address, which is this address down here, to the edge router for LAN 1. Okay, let's go ahead and enter in this in. So it's IP space route space our destination IPv6 network address for LAN 1 2001 DB8:1:10:. Once again, network addresses end in 0, so let's go ahead and enter that in. 2001:DB8:1:10:, and we have to put our prefix in there, /64. That needs to know how much to compare it to. We have that, and now we want the next hop IP address. Once again, we're going from ISP1 here down to the edge router. We need this IPv6 address right here of the serial 000 interface. Edge router, serial 00 interface, IPv6 address right there. 2001 DB8:8:1:2. Go ahead and enter that information in. 2001 DB8:A:1:2. Make sure that's what we had. Yep, that's what we had. And because we're connecting into an established IP address right here, we don't have to specify the prefix or the subnet mask because we're not creating it. We're just connecting into the established address already. I do have a typo. Once again, Cisco's operating system. No news is good news. If you do something wrong, it will tell you about it. Right here, it's saying I did something wrong. The caret is here. I put in this address, this IPv6 address, but I told it to use IPv version 4. Right here, notice it says IP, which defaults to IPv4. I put in IPv6 addresses. I need to go and make that change. What I'm going to do is hit the up arrow once, left arrow all the way over to the end of IP, put in v6 in there, and hit enter. That connected that one, or that set up that route down to 41B, So on ISP1, do the same thing again, but connect to LAN 2. LAN 2's network address. The information's right here. We can go ahead and do that. So we start off with IPv6 route. Now we want our IPv6 network destination network address 2001 colon db8 colon 1 colon 11 double colon /64 for our prefix. And now we want the next hop IP address. Once again, we're on ISP going to the edge router. We're connecting into this serial 000 interface. We need the IP address, which happens to be the same address we used in the line before, because they're both, for both of those routes, it's the same next hop IP address. We can just look at the command we entered in right here. And there is our next hop IP address, 2001 colon db8 colon a colon 1 double colon 2. That entered in that other route, that static route, to get to LAN 2. Part 4, step 1 is done. On to part 4, step 2. Configure IPv6 floating static routes to the internal LANs. Configure to the internal LANs. So on ISP1, we're going to configure the next hop IPv6 floating static route to LAN 1 through ISP. First, what we just did previously, we went from ISP1 to edge router down to the local area networks. Now we're going to go from ISP1 down to ISP2, and then ISP2 will send the traffic over. Okay, so on ISP1, configure a next hop. So we want the next hop IP address, floating static route. We got to give it a higher number than 1 for the administrative distance. We're going to do 5 to LAN 1 through ISP router. We need the next hop IP address of LAN 1. Okay, let's start with this command off. IPv6. We're doing routing, so the next word is route. Destination network is over here. This is the network address for LAN 1, 2001 db8 colon 1 colon 10 double colon /64, 2001 colon db8 colon 1 colon 10 double colon /64. And now we need the next hop IP address. The next hop IP address, once again, needs to be on a network connected to me. So our ISP network is right here. The network goes through the switch. It goes down to the other router. Networks start and stop on routers, not switches. So this is the entire ISP network. And what we were looking at is the IP address on this network, but it's on the other router. That means we're looking at this address right here. This address. If we click in the window and mouse over it, it will tell us that on ISP2 we are looking at gig 00. We need that IP address. If we scroll up to our addressing table, ISP2 gig 00, ISP2 gig 00, we want the IPv6 address. We can go ahead and enter that in our command, 2001 colon db8 colon f colon f double colon 2. Don't need the slash number. We don't need the prefix in there because that's Windows established. But we do have to add one more thing in there. Remember, we are creating that floating static route. We are creating that backup static route. So we have to give it a higher number, higher administrative number than the default of 1. We're going to use 5. Go ahead and hit enter. Now we need to do the same thing again, except for LAN 2. We have to do the same thing, but for LAN 2. Start off with IPv6. We're doing a route. Here's the network address for LAN 2. Go ahead and type that in, 2001 colon DB8 colon 1 colon 11 double colon /64. And then the next hop IP address from ISP1 to ISP2 is this connection right here, which is the same IPv6 address we used in our previous statement. We can go back here, we can look at that. Go ahead and type that in, 2001 DB8 colon F double colon 2 space, and then we have to change the administrative distance to something higher than the default of 1. We're going to use 5. Go ahead and enter that in and press enter. That enters that command. That takes care of part 4, step 1 and step 2. If your configuration has been completed correctly, you should be able to ping the web server from the host on LAN 1 and 2. In addition, if the primary link is down, connectivity between LAN 1 host and the web server should still exist. Let's go ahead and just check that out quickly. We're going to open up PC1 here. I'm going to come up here, open up my command prompt. And then I'm going to ping from PCA here, not PC1, sorry, PCA. I'm going to ping the customer server. I'm going to go ahead and type ping. I'm going to scroll to my addressing table. Customer server's IP address is 198.0.0.10. 198.0.0.10. It's thinking about it. It's going to think hopefully a little bit more. What it was doing once again is what? ARP requests. It had to figure out how to, the MAC addresses, to get those layer 2 frames delivered to the next hop. And then the routing protocol took care of routing it. And then it went back on the frame and delivered it. If I do an up arrow and hit enter to repeat that command, all 4 pings should successfully work. We're going to go ahead and try PCB. Just to make sure we have that working. Open that up, type in ping 198.0.0.10. And it works again. Because all of our devices knew the MAC addresses and was in the ARP cache, we didn't have to wait for it to do a lookup. So both PCs on both different LANs can ping our customer server. On to part 5. Part 5, configure host routes. Users on a corporate network frequently access the server that is owned by an important customer. In this activity, you'll configure static host routes to the server. One route will be a floating static route to support redundant ISP connections. The host route is very similar to the static route, except when you specify the network, you're going to specify the IP address, and then you're going to specify, instead of having a /24, 25, 26 in there, so that you'll have some ones and some zeros, you're going to put in a /128. You're going to put in a /32. You're going to compare all the bits. You're going to make sure that that gets to that server, that packet is going to make it to the server. Okay, part 1, step 5, or sorry, part 5, step 1, configure IPv4 host routes. On the edge router, configure an IPv4 directly connected. Directly connected means we're going to use an interface host route to the customer server. Let's open up our edge router, log back in again, type in enable and config T. We're going to configure this IPv4 host route just like a static route. So we start off with IP space route. Now we're actually going to put the full IP address in of the corporate server. Coming up here, full IP address of the corporate server is 198.0.0.10. 198.0.0.10. And now for our subnet mask for this host route, instead of putting what the subnet mask is, we want to compare all bits. So we're going to put in 32 ones. If you turn that into dotted decimal notation, you're going to get 255.255.255.255. You're going to get 4 255s. Some people call them quad 255s. And that's going to set up looking for this traffic. Anything that matches exactly those 4 dotted decimal numbers. Now we're going to send it to our directly connected interface. And so for here, what we're going to do is on the edge router, we're going to send it to the ISP1. We're going to say that this is the primary route because we've done this as the primary route before. If I click in the window, that's this connection right here. We're going to send it out this interface. This interface, if I click in the window, mouse over the triangle, it's going to tell me for some reason I disconnected it. Now I reconnected it. I mouse over it. It'll tell me it's serial 000. Up arrow gets me back to where I was. And so we have to put in our exit interface of serial 0/0/0. That sets up our host route. Now for step B1, or sorry, for part 5, step 1B, we have to set up a floating route, which is going to have an administrative distance of 5. Once again, using that directly connected idea. Go back into our edge router. Our edge router, we're going to say IP route. We're connecting into the same customer server again, 198.0.0.10. Make sure you type that in there correctly. We're going to compare all of those bits. So we put the quad 255s in. 255.255.255.255. And now this one is going to be our floating one. We're not going to take the same route the primary did up to ISP1, but we're going to take the route to ISP2. If I click in the window, mouse over this other triangle, we're going to see that we're going out serial 001 interface. We can go ahead and enter that in there. Serial 0/0/1. And one last thing we have to do. This is a floating route. Floating route is our backup route. That means we need to give it a higher number than the default number of 1. Our administrative distance, because we always use the lowest administrative distance. That's the trustworthy of it. We're going to give it a higher number. We're going to go ahead and set that as 5. So after your interface, put a space and a 5 in there. That will set up that floating host route for you. And then down to part 5, step 2, configure IPv6 host routes. On the edge router again, configure an IPv6 next hop. That's next hop IP address. Host route, that means we're going to put the whole IP address in there and all zeros for the, we're going to compare all bits of that 128 bits of the IPv6 address. So it's going to be a /28. And then because it's next hop, we have our next hop IP address, server through ISP1. So first one, we're going to go through ISP1 and we'll get that set up. Okay, we're on edge router 1, or sorry, edge router. We start off with IPv6 route. Then we want the IP address of the server. Right here is the IP address of the server, 2001 DB8:F:/F:/10. 2001 DB8:F:/F:10. And we want to compare all 128 of those bits. We're going to put in a /128 because it's a host. We're looking for a specific host and not a network. And that completes the command here. Oh, no, it doesn't. Does not complete it. We have the IP address. Now we need to tell it what the next hop IP address is. We're going from edge router to ISP1. It needs to be on a network directly connected to the edge router. That means that it's this WAN connection, but it can't be the IP address on edge router. That means that we're looking at this IP address up here on ISP1. If I click in the window, mouse over my triangle, it'll say on ISP1, we're looking at the serial 000 interface. Scroll to my addressing table on ISP1, the serial 00 interface, the IPv6 address is right here, 2001 DB8:A:1:1. That would be our next hop IP address. Go ahead and type that in. Make sure you have a space after your /128, 2001:DB8:A:1:1. That will point it to the IPv6 address up here on this interface, our next hop IP address. Finally, last step is to create a floating host route going to ISP2. Floating host route. Create a host route with a higher number than 1 for the administrative distance going through ISP2. We start off with IPv6 route. We're still going to put the same server address in there because it's the same server. We just have 2 paths to it. 2001:DB8:F:(F:10). Compare all 128 bits, so it's a /128. Now we need the next hop IP address. Nope, we're looking for a directly connected network. We are going from the edge router to the ISP2. This is our connection here. This is our exit interface, that directly connected. If I click in the window, mouse over this triangle, it will tell us we are looking for serial 000. Sorry, start that over. Serial 001 is our exit interface. We can go ahead, enter that in after our /128 and put a space, and then serial 0/0/1, that is our exit interface. One last thing we have to do is specify that higher administrative distance to make it the backup route. And so make sure you put a space in there after your interface and then the number 5. Okay, that completes the lab as the instructions say, but there is one little issue that we do need to look at. How the lab scored it is for that last IP host route, the floating one, the instructions, it said use a directly connected, so that's the interface going out, but the scoring actually looks for that next hop IP address. If we look down here, we can see we are at a completion of 93%, meaning we didn't get the last one correct. What we have to do to get the scoring correctly is change this from the directly connected exit interface to and next hop IP address. Let's go ahead and change that quickly. What I'm going to do is just hit the up arrow once, arrow over, get rid of the serial 001. And now what we're looking for in our diagram is it's this connection right here that goes between the edge router and ISP1. Needs to be on this network, but not on the edge router. It needs to be on ISP. We're looking for the IP address of this interface right here. If you click here, mouse over the triangle, it'll tell you it's the serial 001 interface. So we need that IP address. Scroll up to our addressing table on ISP2, serial 001. The IPv6 address we need to put in there for our next hop address is 2001 DB8:A:2:1. Let's go ahead and put that in there. 2001 DB8:A:2:1 is that address. Go ahead, put that in there, hit enter. Now notice our completion is went up to 100. I'm going to try and fix this packet tracer lab, and You may get the 100% with just the interface. If I don't, just do this one little change here at the end, and you'll have the 100% completion. That was Packet Tracer Lab 15.6.1, Configure IPv4 and IPv6 static and default routes. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.